All right, folks, grab a seat. There's still some room around here. If you want to pull chairs around, if we need more seats, let me know. I can grab more out of the back room. We'll try to not make anybody sit on the floor. It's not comfortable here. All right. Hi, my name is Jim Gall, and I am a professor across the street at UW Tacoma. I have been running the Think and Drink and if somebody could slide that door just not all the way closed, but partially, it helps deaden the noise about this much. It's going to be noisy, but hopefully you guys can hear. Everybody hear okay? Brought this mic in. Excellent. So what was I saying? Oh, I've been running the Think and Drink now since pre-COVID. We had to go online for a couple of years. But I'm really happy that we're back in person and partnering. Unfortunately, we lost our partner at the Swiss, which I believe this t-shirt still has the Swiss on the back. But we're really happy to be working with 7Cs and the folks here. For those of you, how many people are new to Think and Drink? A lot of you. Excellent. The running thing is the new people buy beer. So I don't know if anybody told you that when your friends invited you. But that's hopefully the way it works. Haven't gotten anybody to fall for it yet. But the way we do this, every second Tuesday of the month, we have, except for we're taking a little bit of breaks in the summers, but we have a speaker. So second Tuesday, you can put it on your calendar if you want to actually get notified so you find out what the things are. You can either remember to go to the website. So if you just go Grit City Think and Drink on your Google, you'll find it. Or if you scan that QR code, you can actually sign yourself up for the listserv. And I don't ask for anything except I just send you stuff when we're giving a talk so that you know it's coming up. So if you're interested, you can scan that and add yourself to the listserv, and you'll get the notices every month when we do the talks. All right, so I'm going to, in just a second, so wait, I should mention the people who, well, they don't pay me. The people who sponsor this by paying for some of the stuff. So my folks at the School of Interdisciplinary Arts and Sciences at UW Tacoma, and the Office of Community Partnerships at UW actually helped spring for some of this. And then 7Cs provides some in-kind stuff. So we're very happy to have all our partners for this program. All right, so, the way it's gonna work. So I'm gonna introduce our speaker. She's gonna come up here and wow you with the talk. And then she's gonna get a short break. We're gonna give away some prizes. So there's some free swag. I will give out some, as she starts, I will start to hand out some raffle tickets probably afterwards. We'll give away some prizes, and then you can play Stump the Speaker with your questions afterwards. Sound good? Yes. All right, so without further ado, I will introduce our speaker and put her talk up. Kristen Jenkins, who has a PhD from University of Minnesota, but she has her bachelor's from a local place called Western Washington. She's a biological anthropologist and archaeologist at TCC, where she teaches courses on bioanthropology, archaeology, primates, and human osteology, which is bones. Got it, okay. Says the guy who's a chemist. Her research interests are in restructuring predator-prey relationships of fossil apes and fossil humans. Kristen has been studying fossil site formation in Eastern Africa, which is a place I hold near and dear, on various projects spanning the last 20 million years of human and ape evolution since 2009. So without further ado, Kristen Jenkins.
Hey, thank you so much. I see there's a handful of people still walking in. We have a couple seats. They're over here. Someone can sit next to my esteemed husband also. So I have to preface this with back in 2020, in late January 2020, I actually took a workshop on how to give a good outreach talk at a bar. And I quickly filed that away under things I would never need to know again because the rest of 2020 happened. And then I came up with this ridiculously long and convoluted title just at the beginning of September while I was recovering from very serious jet lag. I had just gotten back from Kenya after a month doing field work, and I also came down with COVID. So there it is, my title, Morodopithecus, Ikembo, and Friends, Collaborative Research on the Adaptive Environments of Our Earliest Ape Ancestors and All the Other Critters They Lived With. So, but what I want to talk to you about today is a little bit about what fossil research is like in Eastern Africa. I want to talk about these to me, very interesting early apes. And I want to talk about how collaboration, not only with my fellow researchers, but with the local communities and where we work, how that has all made this come together. So that's sort of what I'm going to do today. Okay, oops, there we go. So I am a paleoanthropologist, and that falls under the umbrella of anthropology. And anthropology is, in my mind, beautifully broad. It is the study of people. And in anthropology, that means we study our cultural diversity. It means we study the many ways in which we speak and communicate. It also means we study our physical selves and how evolution has shaped us. And it also means we study our human past through all the stuff and trash that we leave behind. Now, me as a paleoanthropologist means I am studying the human fossil record. And that means I've been cross-trained in both biological anthropology and archaeology. And I've been fortunate in this study to kind of go to a lot of really exciting places. I started out doing some research in southern Russia, in the northern Caucasus. This is a Neanderthal cave site. I got to study the things that Neanderthals were eating and the meals that they left behind. And honestly, like, this hooked me. If any of you are other faculty out here, give your undergrads opportunities to do student research, because that's why I am here today. I also went to, not so far from there, in the southern Caucasus in in the Republic of Georgia. And under these beautiful medieval ruins, there were 5 other Homo erectus specimens. These are some of the earliest hominin inhabitants of Europe, people coming right out of Africa and starting to populate the rest of the world, happening right there. I also got to do some excavation in the beer fields of the Czech Republic. If you are getting your beer, you can thank some wheat fields for that. And that was a less pleasant place to dig, especially whenever the combines went by. We got dusted pretty well. But this was a site where we were tracking some of the earliest modern humans coming into Europe. And we're looking at their tools that they left behind as they passed through this field. But where I have kind of landed in my work and my research is in Eastern Africa, and in much different time periods. So, you know, in anthropology, we're interested in humans. But if you really want to understand humans, you need to understand those who came before us as well, our earliest ape ancestors. And so the work that I've been doing is on the shores of Lake Victoria in Eastern Africa. What's that? Got aerial photo here, kind of like a crater. Can you guys tell what this is? This is a volcano. It's an ancient volcano on the shores of Lake Victoria here. And this is a volcano that is about 20 million years old. So this is a volcano that's been spitting out ashes, laying down lots of layers. And as it did this, there were lots of critters all living there. Lake Victoria, which is seen in black there, it was actually not there at the time of this volcano was doing its volcanic thing. So it's like partially eroded. The islands there, let's see, which of these is there? Oh, there's Rasinga Island, where I've been fortunate enough to do a lot of work. It's basically a down-faulted portion of this volcano, and it's littered in fossils. And then we also have nearby Mufangano Island, also part of this volcano complex. And then there's another little site over here on the edge, on the flanks of this volcano. And this is sort of a nice artistic bird's eye view of this area. And as you can see, there's lots of different layers here, right? And on Rasinga, you can see there's lots of exposure. We have some exposure on, just part of the side of Mufangano, but what you really need for good fossil sites is a lot of erosion. Of course, the erosion isn't good for fossil preservation, but it helps you find them. Now, I think that this site is one of the most beautiful places in the world. I would spend it's hard to compete with Washington State, right? But here on the shores of Lake Victoria, we have colorful boats, beautiful, and red sediments. I'm never gonna get tired of like colorful boats. This is part of our research team. They're getting in a boat and they're going to one of the other islands. And beautiful sunsets. The fossils aren't bad either. These are just some of the fossils I'm going to show you today. They are the prettiest ones, but I've been to a lot of different sites. And this is one where you can't walk around without tripping on more fossils. It's that fossil rich and dense. And part of the reason it is so dense is because of those volcanic ashes, not because it's all a catastrophic mass death assemblage that, the volcano like killed everything Pompeii style every time, but just because those sediments offer so much mineralogy that can percolate into those fossils and help things fossilize. So Rasinga Island here has been especially important for understanding early ape evolution because there are so many different fossil apes that are so well preserved. The one I'm going to talk about the most here today is Ikembo, and we actually have two species of Ikembo, but they're very closely related. We have like a bigger one and a smaller one, and but they got some other friends. We got a Dendropithecus, we got a Limnopithecus, we got a Nyanzapithecus. Pithecus just means like ape man, so it's like sometimes we actually found a fossil and we were going to name it after like one of our museum collaborators. His name is Blasto. It's just a great name. He's a great guy. We're like, oh man, we got to name it Blastopithecus. And we're like, no, we can't name it Blastopithecus. Like, and a lot of fossil sites maybe just have pieces of fossils. I mean, anytime an organism dies, the odds that it fossilizes are actually quite small. And it's even smaller that you get the whole skeleton. But when it comes to some of these fossil apes, we have so much of their body. We actually know most of what their entire skeleton looks like. And when we know what their skeleton looks like, we can start to piece together how that organism moved, how it ate, how it chewed, things like that. We can start to build this picture of what these organisms were doing when they were alive. Now, it's not just the fossil apes here. We actually have an incredible ecosystem that's preserved here. This is a fossilized reptile head. And you can see it actually has some of the skin still preserved on it. This is an adorable chameleon. It's this big. It's one of the most beautiful things I've ever seen. We actually found some more chameleon teeth this year, just like a little piece of a jaw. Like, I mean, chameleons aren't that prevalent on a landscape anyway, to find their little jaws. Oops, yeah. All right, we got chameleons. We have organic things that don't typically preserve. And again, it's because sometimes we get those ash falls and we have such mineral rich sediments here. We have pieces of wood, endless fossil sticks. We don't even collect the fossil sticks anymore. There's too many of them. We have things like little fruits. There's fish, grasshoppers. More fossil fruit. This is my pal and collaborator Cliff at the National Museums of Kenya. He's a preparator, a fossil preparator. And we were working on Mufangano Island, and we were just sort of like passing through this site that we kind of check on every other year, and found a couple of these fossil fruits there. Fruits don't typically preserve. Like, we know those things rot unless you're really, really lucky. We actually ended up finding 7 of them all together. What I really want is when we're done preparing those to see like a nice like ape tooth pit in the middle of it. But I'll wait. all these other amazing critters are found here too. We have some really large carnivores, except they're not carnivores like we think of carnivores today. They're actually not related to modern carnivores at all, but they're doing the same types of things, like having big, scary teeth and eating other critters. And this is something called a creodont or a hyenodont. This tooth here is probably about this big. That's a fossil nope to me. It's probably similar to this other fossil that was recently named from a relatively nearby site called Simba Kubwa. That just means big lion in Swahili. Creative names. Sometimes we have fossil poop or coprolites. This is, when I'm having a bad day, I think about this fossil. I'm like, this too shall pass. But this is actually a bone. That's a bone that's like this big that's stuck in a coprolite. I'm guessing maybe it was theirs. We have lots of little cute things too. We have some of the earliest true carnivores. This is one of the first fossil cats that is found in Africa. Again, about like 18 million years old. And it was probably gotten by some sort of avian predator, some bird of prey, because it was found with a lot of other things that were clearly gotten by some large bird of prey. And, eating off the rest of the cranium is a pretty common thing to do. We have little bunnies. We have hyraxes. Has anybody ever had the opportunity to go on safari or anything? All right, so hyraxes are kind of like cute little fluffy blobs. But these fossil hyraxes are like large, and I don't know if they're fluffy or not. They're quite interesting. We have a really interesting assortment of large mammals too. I want you to imagine, this is a calicothere, and if you imagine like a horse, but it has like knuckles like a sloth and walks like that you have a calicothere. So we have some animals like these that we kind of recognize, and then we have other taxa that are completely different from anything we're seeing today. We have cute little, they're called Dorcatherium, dork part. And imagine like the cutest little like goat deer that's like nay big. We have ancestors of the hippos. That cranium is about this big. We have lots and lots of crocodiles. We have probably at least 2 different taxa. The dig I was working on this summer, we had a ton of crocodiles. I don't even know how many individuals we'll have when it's all said and done. Probably 20 or 30, I think, all dead together. And one of the things we're interested in doing is also like, oh, how do they interact with each other? And how did they interact with their prey? So we're doing things like looking at the tooth pits that they leave on other bones as well. So all this is to say is we have preserved here a very stunning fossil ecosystem. And most of the time when you're thinking about reconstructing the past, you just have a piece here, you have a piece here. And on this island, the fossil deposits, we almost have too much to make sense of, right? So trying to piece together these clues, these pieces of evidence to understand what the environments were actually like. We want to know how these animals live together. We want to know what the adaptive environments are for all of these animals, but I'm an anthropologist, so I'm especially interested in the fossil apes here. By adaptive environment, I mean, how did their environments force their natural selection? How did they change as a result of being in those particular environments? Now, what comes with this is a lot of assumptions, and I'll come to those assumptions in just a second. All right, so what, who cares? I mean, I care and you're here, so I guess you care, but what's the big picture? There are some important implications for understanding these past environments. Those implications can be thinking about habitat restoration, conservation. It can be thinking about how are our modern apes adapting to environments and things like that. So if we think about the living apes, let's come back to the future. No, the future. The future is now. Let's come back to the present. If we think about our living apes, there actually aren't very many. There's you and me. We got our chimpanzees and our bonobos. Here I am with a chimpanzee at an old Pejida. It's a conservatory in Kenya. Chimpanzees aren't actually native to Kenya. And I've been studying primates and anthropology a long time. This was one of the first time I'd actually been able to come face to face with a chimpanzee. And I was there, I was admiring their fingernails. That's something we share in common with the other apes and primates. We have nails instead of claws or hooves. We also don't have a tail, things like that. Tendency towards upright body posture. I'm hitting there and we're having a moment. We're looking at each other. And he just like rips ass. I'm like, wow, we share so much in common. But we also have our gorillas. You can see the gorillas at Woodland Park Zoo. We have gibbons and Simons. You can see those at our own Point Defiance Zoo. And there's orangutans at Woodland Park also. But we only have a handful of these modern apes, right? It wasn't always that way. In the early Miocene, this period that I'm talking about 20 million years ago, you actually have as many as maybe 20 different genera. I only got like 3 or 4 different genera here. Where did all of our apes go? Why do we see this shift in a decrease in ape diversity through time? And that's one of the things we're really interested in understanding too. So let's get back to those assumptions about the fossil sites. There's this general assumption, and I guess we're basing this on our modern apes. We assume that the fossil apes would have had to have evolved in densely forested habitats and environments. And that's really because almost all of our fossil apes, with the exception of ourselves, were incredibly adaptive, are living in densely forested tropical environments. We assume that the fossil apes are also going to be eating a lot of fruit. Now, a lot of our modern apes today, they can dabble in a lot of other things, but their diets are still generally dominated by fruit, with the exception of gorillas. They're kind of specialized there. And there's also this assumption that grasslands are spreading much later. The earliest documented grasslands and widespread in Eastern Africa, or just in Africa, were about 10 million years old before our research team came and pushed that back a bit. Now, this is, welcome to my classroom. If you have ever taken like a science class, you've probably heard a little bit about the scientific method. And this is a corny slide that I show my students to make this a little bit more interesting. But the scientific method is really this consistent way of conducting scientific investigations. First, you have to come up with a hypothesis, which is just a fancy name for an educated guess. I like to tell students that they've been doing science since they were toddlers, where you get an idea and you're just gonna like test it over and over and over again, and you're observing, you're seeing what happens. You're getting data. Now, good scientists will take that data in their mind and evaluate it, be like, oh, does it actually match what I thought was going to happen, what I thought my hypothesis should say? And they will revise their hypothesis accordingly. And then and only then, after you have tested your hypothesis over and over and over again, and lots of your friends have done it too, or maybe some of your enemies have also done it, then you can advance it to a theory, right? Ultimately, science is a self-correcting process, which I think is part of the beauty of it, if you're doing it right. If you're doing it right. Now, one of the things about paleoanthropology and kind of the paleosciences in general is that is the testing and observations part. If you're digging a site, you only get one shot to do it. You only get one chance to dig it right, to collect as much data as you can while you're taking it out of the ground. If you're doing a physics experiment, everybody in your classroom can do the same physics experiment over and over and over again, right? But I can't dig up that site over and over again. Also, we want to be able to have lots of sets of eyes on something, right? The more eyes on a hypothesis, on data, are going to help you understand that hypothesis and revise it if necessary. And one of the things about fossils is that you can hoard them. You can't hoard gravity. Can't hoard plate tectonics. You can't hoard all the bacteria and viruses. That's what elementary schools are for. But you can hoard fossils. And I don't think I'm talking out of school here when I say that paleoanthropology as a discipline kind of started to go the wrong direction here. And I think we've all been in like a toxic work environment or a group at one point or another in your life. We don't have to talk about it right now. But I mean, what happened was it's documented. You can go read the books. You can read the papers about it. Was in some of these later time deposits, later time deposits with kind of the development of bipedalism and stuff like that. People were sort of like keeping their fossils for themselves. You had a kind of academic nepotism. And that meant that you couldn't really test those hypotheses in a thoughtful way. It only takes a few personalities to kind of change things. But I think it only takes a few personalities to kind of change things back as well. Right. So I want to go back to my research team, the original one that's working on those volcano deposits that I talked about. We started trying to just throw the kitchen sink at trying to understand these paleo environments and these animals that were all living together. We were looking at fossil leaves, fossil communities of all these animals that were living together. We started to redate all of our sites. We're looking at the sedimentology to understand what kind of is there a lake? Is there a river? Things like that. And getting lots of fossil specialists involved. We can even do these things called isotope analysis, where you can actually, it's a destructive analysis, but you can take just a little part of a tooth and you can do kind of like a geochemical analysis. You are what you eat, and it'll start spitting out data that'll tell you oh, it was eating this kind of plants or this kind of plants. And I can tell you what's in that environment too. My part of this research is I am the team taphonomist, and that means basically I study fossil forensics, or how did these critters get dead together. So I'm looking at marks on the bone, how they're preserved. And this can tell us, should I expect to see all these animals here? Are some of them not going to preserve anyway? What can I tell about the interactions with each other? Things like that. And as we started to work on this, getting ahead of myself. So kind of back to my question about what good science should be. I think in paleoanthropology specifically, you need to be able to share your data, but I have an asterisk next to that. And that's because when I go to East Africa or any other country, I'm a guest. We have this sort of Western paradigm of what science needs to be. It needs to be shareable amongst everybody. It's the globe's heritage. But in this case, it's Kenyans. It's their fossil heritage. And their museums are the ones that are going to control access to that. So, data sharing needs to be done in consultation and in collaboration there. So that's why I have an asterisk next to that. It needs to be inclusive, having as many eyes on things, as many different perspectives as possible. That's how you test your hypotheses. That's how you elevate things to a theory, when you've tested it as many different ways as you can. You got to work with stakeholders, and stakeholders are going to take lots of different forms. I can't give you a formula for who is a stakeholder in any given situation, but I know that when I'm working on this research, I'm thinking about the local communities where these fossils come from. They're letting me on their land. They're curious about these fossils as well. But there's also the national museums. There's also students. There's you guys, all the outreach that we can do. And it needs to be reflective. How are we considering our hypotheses? Are we questioning our old assumptions? So enter the reach team. So the reach, we've made lots of jokes like, oh, this is going to be kind of a reach, but it stands for Research on East African Catarrhine and Hominoid Evolution. And as our research team, we're working on Rasinga, we're getting all this great data, but we realized we didn't really have anything to compare it to. Like, okay, we got a great site here, but if we really want to answer these questions, we need to like think bigger, and we need to understand like the big regional perspective as well. And one of the things that was revolutionary about the REACH project is instead of all these little teams that were working separately and kind of siloed in their own work, we had, and it really just started with two people like, hey, what if we all decided to do the same types of methods and we all visited each other's sites and we all looked at each other's fossils and we could get as many eyes on it as possible and we could really test these hypotheses together. And that grant, which was launched in 2013, 10 years ago today, that was a $500,000 grant. Didn't go very far, turns out. But the research papers that our team put out in Science last spring, there's at least, I think there's like 37 authors between the two of them. There are, I want to say like 6 or 7 different nationalities in our team. There's a bazillion different institutions there. It's been so wonderful working with a big team. And what doing that has taught us is like, we really need to kind of set aside our own territorial instincts. We have to set aside our own egos for a minute. I'm not going to pretend that we all love each other all the time, but it's been a really amazing experience. As part of that team, I traveled with the geology and taphonomy team, and I was the taphonomist and everybody else was the geologist here. And we went around to several different sites in both Uganda and Kenya to examine these things. We had a couple different dating specialists. We have Rahab here was my fellow lady on this team, and she was studying phytoliths. Phytoliths are little tiny silica pieces that plants drop. And sometimes they can preserve, they can tell you which plants were living in the soils. It's incredible. We didn't even think they would last this long, but she discovered them there. Now, fieldwork can be intense. See what I did there? I'll be here all night. It can be tough living out of a tent for a long time. You really have to have a good tent. Sometimes we have rainstorms. Sometimes your tent is just too hot. This last season I was out there, I actually opted to stay in the house because we have a permanent field camp now, and our team leader built a house there. And I was like, you know what? Coming up in the world, I'm gonna stay in the house. And I was so hot in the house. I'm like, oh, I wish I'd stay in the tent. Sometimes fossil research is hard. Here we are helping each other across the Turkwell River. We had to go through this barefoot because it would just suck your shoes right up, and you just sort of like hope there's no big old acacia thorns in there. I have gone on what thought was just supposed to be like a 7-hour tour. It turned into like a 4-day tour as we repaired the Land Rover over and over and over again. I've been sick. And my friends, they take me to the good hospital, and pay as you go there, but it's still so much cheaper than it is here. And sometimes we have bats in our pit toilets also. I did not make this figure myself. This was actually from a published paper. And turns out you have to watch out for bats because it's nice and toasty in there. So they like to hang out there. And if you don't cover up your pit toilet at night, you got to like kick it, make sure the bats fly out so they're not there while you're trying to go. But through all of these sort of trials and tribulations, the local communities are the ones that are showing us the way. They know where these fossil sites are. They know how to take care of us, and they are so generous in taking care of us. I have built some really incredible friendships, I think, along the way because of these communities. And these are some of my like happy feel good pictures here of some of the people I've been able to know. This is one time we were like tromping through Western Kenya, and my friend Sam, he is the head of paleontology at the Kenya National Museum. So we were on his project, and he's like, "Oh, we got to go to the Good Lunch site." And so we drove over to the Good Lunch site. It's on somebody's land. This was a church. We had lunch at church one day, and I've often been doing digs, and the school kids want to come by, and their parents are usually working on the dig. So like I'll talk a little bit, but I'm mostly letting their parents explain like what it is they're doing, what they're finding, because they're really excited that their dads are working on the site here. We've had a we've as we're sort of kind of working with communities more, we met up with this guy who's another anthropology student. He did his anthropology degree at University of Nairobi, and he has a little bit of background in like recording oral histories. And so I was like, hey, George, we got to get you started on like, can you talk to the elders of these communities if they've ever worked with the researchers before? And one of the things in his interviews that he's found that like people were really excited that we would eat with them. I'm like, oh my gosh, of course we'll eat with you. That's what we've been doing. And we've often on like some of the digs that I've led had, you know, community members just bring by snacks and food for the whole group. I have felt, even though sometimes things are tough, I actually brought my husband and my 5-year-old daughter, and I brought her when she was 1.5 as well. Here she is doing a little bit of fossil hunting with dad, just having a blast. And I'm gonna quote one of my colleagues here, his Twitter. You know, if you're quoting Twitter, it's good, right? That's how you know it's legit. Find it. So this is what he said. He said, a world-renowned neuroscientist once told me, with no preamble or context, that science is friendship. It has taken me years to unpack the meaning behind that simple phrase, but the depth of his insight became clear to me as the REACH project developed. I don't know, to me, it seems very obvious. Science is trust in your colleagues. You're trusting that they have faithful observations. It is respect, because you have discourse with one another and you can disagree and you can converse about these things and kind of come to ideas together. It is vulnerability in that discourse as well. And it needs to be reciprocal. You're working together for this common goal. And, you know, it helps that you have shared interests, right? So you're hanging out together a lot anyway. To me, and some of the most, you know, incredible friendships I've have been built out of this research. And because of some of those research, this has given us the opportunity to do more thoughtful outreach in these communities. You know, research is hard. And sometimes living is hard too. And we are researchers that come into these communities with a lot of money. And even when I am in the depths of my, oh my gosh, how am I ever going to pay my student loans back? I still have more access to capital than most of the people that we work with. And we were kind of getting solicited for help a lot. And sometimes it kind of felt a little bit overwhelming. This guy here, Sam, is somebody that I've been working with since 2009 when I started. And he was basically like the crew chief for me. He handled all of my hiring. He did a lot of translating. He helped the excavations run really smoothly. And he ended up being like a really good friend. Well, one of the things, Sam is just like a go-getter and a leader. And he saw things in his community that he wanted to change. And it started with kids. There's a HIV epidemic on Rasinga Island, and that meant there was a lot of children who maybe aren't like orphans in the way that we think of them, with no living parents, but maybe just one parent, or they had extended family, but then they're absorbing more children, and it was difficult for a lot of these communities. He also saw trash around, and he didn't like that. He saw widows that were struggling, and he just wanted things to be better. So he gathered a group of like-minded people on Rasinga and just started doing it. And then he approached our team. He's like, hey, you guys should give me money for this stuff. We're like, okay, we'll do it. and that's really how Kate's started. And I'm gonna need to always remember what Kate's stands for. It's the Center for Advocacy and Intervention on the Talents in Healthcare, on Talents, Healthcare, and Sanitation. So like really broad umbrella of what Sam and Kate's are interested in. And part of this was Sam wanted to start a school. And so one of my colleagues, he was just like, okay, you want to start a school? I guess we can find some money for that. And he was very smart. He decided to name it after his parents. And he has like 7 brothers and sisters. So they all threw money at it so they can name it after his parents. It's the Kathy and Mike McNulty Academy. But what that school does is it focuses on quality elementary education for students that were generally orphans. They provide meals for them. They're giving them thoughtful trauma-informed education. One of the things that Sam is also interested in, and he pegged me for this, he knew that I was the one to go to, that he's like, hey, girls aren't staying in school very well. I was like, oh, okay. I was like, well, because of period poverty. And that's exactly what it sounds like, that girls can't afford, or their families can't afford menstrual products. So they end up missing 20% of their school by the time they're in secondary school, because they're out for a week each month. And so Sam went to bat with his team, doing outreach in the schools, and tapping me and anybody else who wants to help me provide period products for students. So one of the things I did out this year was Sam took me along to this school that they'd been working with, and the kids told me about what they're doing. And sometimes I have to give an awkward speech, and this was probably one of the most awkward speeches I'd ever given. I had to talk about being nice to each other while you're on your period, and how it was great that they were actually just reducing stigma, not just with girls, but with boys as well. So it was a co-ed educational program. Oh my gosh, I never had anything like that. Did you guys have? No. And we didn't talk about being nice to each other as you're on your period, and how to thoughtfully tell each other oh, you might be bleeding, and not point and laugh and stuff like that. And another funny story, I was actually, this is sort of kind of a part of a broader movement within Kenya, I think. I was on site one day, and one of my colleagues, he comes hey, I think you've bled through. I was like, oh, okay, we'll check. I just sat in something, it wasn't that. But when he came up to me, he's like, it's for your life. What? So okay, talk to me. What? Oh no, it's for your life. You might have bled through. I'm like, okay, I was thinking bandits or something. No bandits. Anyway, so being a part of this has been really rewarding, to give back to these communities that have given so much to us. And it's really all Kenyan led. It's all led by Sam and his people. Sometimes I think I have an idea, and it turns out my idea is terrible. It wouldn't work at all. It's Sam, you need, the girls want a structure for building, they want a structure for changing. Well, what's wrong with the cheap thing that we have at camp? They're like, oh, the cows will eat it. I'm like, oh, right, sorry, I'll just defer. Another thing that's been happening is a newly developed Rasinga Island Prehistory Organization, or REPO. And this was just born out of really interested folks on the island. It's just a grassroots organization. Research on Rasinga, fossil research, has actually been going on since the 1920s. You'd think 100 years is enough, but no, there's still more questions to answer. And this is where I want to thank Tacoma Community College, because they gave me the funding to actually do our first inaugural outreach event. So last Yeah, it was last year. Gave a little talk at the schoolhouse, and it filled up, and everyone's like, "We have to do this all the time." Like, okay. And we did it again last year, and last year we had so many people show up that we had to do it twice. And the other cool thing is that we get these musees or elders in the communities that come to these. And this is a guy here. He's actually the father of Joreem, who worked with me in 2009, another part of the island. And he worked with Louis Leakey in 1947. If you've never heard of Louis Leakey was one of the guys who kind of started fossil research in Eastern Africa. He's the one who put this site and so many others on the map and really drove home that, yes, the majority of human evolution is happening in Africa at a time when people didn't want to believe that. So we are trying to work on getting them sort of like a community museum, not a museum as a repository, because we need to follow Kenyan laws here. That means that all the fossils have to go to the museum in Nairobi. But everyone on the island is like, wait, but our island is famous for these and we never get a chance to see them. And that's legit. They want to try to turn this into like, some tourism. They want to actually talk about the value of fossils. What are the opportunities for people here to learn about the fossils? Once they go to the museum, they don't really get a chance to see them again. So having a community museum, having casts available, giving talks, showing what we're finding, is something that we're trying to do more and more of. And it wasn't something that I thought it was cool, but this is something that's being like grassroots led. And I'm just really grateful that they will tell us what they want so that we can help make it happen. So I said that most of the time, nobody ever gets to see the fossils again. But this last summer, a few of our repo guys, and these are guys that are working on the dig with me and have worked with our team a long time, they made the trip out to Nairobi to visit the museums and see the fossils, see the back rooms themselves. And it was really awesome to help facilitate that. The Kenya National Museums actually has a vault, what's it called? And it's got a literal bank vault door on it. It's temperature controlled, it's fireproof, it's bomb proof. It's Kenya's most important fossil heritage is kept in this room. And we got to go through the cabinets behind there. These are casts that they're holding up and see some of the original specimens. I actually have a cast of that specimen there. Chris, do you want to show that around for us? This is a cast of Ikembo hazelanai. It's one of the fossils that Mary Leakey found in the 1940s. The running joke is that she sat on it, and that's why it's a little bit squished to the side. But it's otherwise remarkable preservation. All right, so back to the science. Reach team is throwing geology, taphonomy, paleoecology, ecomorphology. Paleoecology just means it's the study of how these ancient environments, what they look like. Ecomorphology refers to how the shapes of the bones of these animals or their teeth reflect the environments in which they evolved. And we went to all these different sites as a team. So we worked on, and the cool thing here is I talked about the volcano down here. Turns out there's volcanoes all over the place. We have the Tinderet volcano, we have Mount Elgon, we have the remnants of the Napak and Moroto volcanoes. These little blobs up here, we have some West Turkana, some Bullock ones, and getting all these sites dated together so we can kind of build a big chronology and then trying to look at these broad scale environmental conditions. So a little bit about what we found on Rasinga and the other Kisangiri volcano sites. Well, we have this ape Ikembo. That's the most, the numerous one. There's that one, it's a little bit smaller, and there's one that's more about the size of a chimpanzee. But they have overall what we'd call fairly conservative body shape and morphology. So it's, it's above branch quadruped. It's got kind of arms and legs that are roughly the same size. It's got teeth that look like it's good for eating fruit. And it lives with a whole bunch of other dead critters too. But one of the things that we're doing in all these different analyses is we see like, okay, there's actually a variety of environments here. Some of these environments are a little bit more forested. We actually found a fossil forest at one of these sites. The roots going out in different directions and fossil tree trunks. Those are relatively common on Rasinga, go figure. But lots of fossil leaves. And we're saying, okay, some of these are more seasonal forests. Some of them are more woodlands, and not shown here because of the leaves, but we also are finding some areas that maybe are a little bit more grassy. Okay, so Ikembo seems like it can persist through a lot of different environments, turns out. And that shouldn't be too surprising, right? We have a lot of different layers that we're sampling. So a big span of time and space. Now, one of the other things the big team was looking at was these phytoliths. And this is sort of what like cracked the whole thing open, because we found grass phytoliths. So this is what they look like under a microscope here. And when we looked at we didn't get phytoliths from every site, but we got them from a few. Rasinga here, the phytoliths that we were getting kind of suggest that like, oh, some of these areas are more wooded and some of them are a little bit more open and more grassy. What is an ape like Ikembo that it looks like it's supposed to be on the branches doing in a grassland? We're also looking at, oops, these other sites. Go back. Oops. Got Morodo here. That was up here in Uganda. And that one's got an ape called Morodopithecus. So this is my Ikembo and Morodopithecus and friends. And Morodopithecus is a little bit older than Ikembo. It's a little bit bigger. It's more chimpanzee body sized-ish. But one of the really things that's fascinating about Morodopithecus is while most of the other apes, and it turns out there's a bunch of different apes at all these sites, but most of them are kind of have this more Ikembo thing going on. They're good generalists. Morodopithecus has some very interesting vertebrae. And I know you're like, oh, what's interesting about verts? Well, let me tell you. These are our human vertebrae here. This is our lower back. You know, evolution gets you a back that just kind of gets it done. It's not going to be like a happy, healthy back your whole life. So this is a lumbar vertebrae, or where you're going to have your lower back problems. And our lower back is big and thick and beefy and robust. And the reason it's like that is because it's got to support all the rest of your weight, right? You got half your body weight stacked on it. If I'm a quadruped running around on all fours, I can distribute my weight pretty evenly. I'm not putting as much stress on any one part of my body, right? Well, we see these beefy verts in Morodopithecus, as opposed to like a macaque monkey, which is definitely a quadruped. So like, oh, Morodopithecus looks like it's kind of tending towards this upright body posture, kind of like a lot of our other apes do. But what's it doing with that upright body posture? The other weird thing about Morodopithecus, and here's me for scale, is that it has teeth that are a little bit more high cusped. If you run your tongue along the back of your cheek teeth here, you can feel all the little mountains and stuff. Those are cusps. And we modern humans have particularly puny cusps. We are chewing a lot of processed foods. It's fine. And truth be told, we've been doing that for like, you know, close to like 2 million years. It's not just a new thing with McDonald's. We've been processing our food for a long time. But Morodopithecus here would not be doing that. They actually have high cusps. And when you have high cusps on primate teeth, it's usually because they are eating leaves or shearing them. Just probably explains why I have such a difficult time like eating lettuce. It just doesn't go well. All right. So when we threw the kitchen sink of all the environmental reconstructions at Morodo as well, paired with this interesting combination of being a more upright ape, okay, probably doing that in the trees, right? And eating leaves, we have this weird picture. We always expected Merodopithecus to be living in sort of a closed canopy forest. You're going to be like grabbing branches like this, right? Well, it turns out it's probably living in something that's much more open. And we're knowing that from the isotopes, from the phytoliths, from the soils. Okay, that's weird. And actually, we learned it from like the fossil preservation as well too, because when fossils are left out on the surface, getting hit with the sun all the time, they weather a little bit differently also. We also generally thought that early apes were really just eating fruit, and Merodopithecus kind of blows that idea out of the water too. It seems to be focusing on leaves. So what is it doing eating leaves in more of an open canopy type environment, and I don't know, having to get from point A to point B, not in the trees? That really blew a lot of our minds here. So we have this reconstruction of like, okay, maybe it's using this upright body posture, not as in like walking sort of along the branches, but actually using it to get up into the tree into the first place, because it has to come down a lot. So very different idea of what we thought early apes were doing. When we looked at all of these reach sites together, what we found is that there are really no clear trends in the paleoecology. We kind of expected to see like somebody's like, oh, maybe they're slowly going to open up, like, you know, get drier or get more grassy or something like that. Or maybe we'll see like, sites in this region specifically that are going to have like a particular ecology, and this one there. But we didn't see that at all. We had a big sample of time and space. We didn't see trends like that. It was actually all a little bit random. However, there was evidence of water being present at all of these sites. We had lots of streams, some lakes, things like that. And the other thing is that all of these sites were sort of dominated by turbation. These were frequently disturbed areas. And we live next to a volcano also, right? When you have a lot of volcanism, you have a lot of uplift, which means you have a lot of erosion. Sometimes your ecosystem gets decimated now and then as you have an eruption. It wipes everything out. What's going to grow back first? Your grasses. And we should expect a lot of volcanism here, right? Because all of East Africa is rifting now. So these are basically plate tectonics. So when you have, or in particular rifting, is basically you have chunks of the continent actually pulling apart here. And this is actively happening today. You have this, this part here, the eastern part rifting away, the western part rifting away. Some of these rift arms are more modern. We had some more ancient ones here and here and up here. But when you have those continents pulling apart, you can have volcanism sort of puff up in the middle there too. So this is a very dynamic landscape that we're dealing with. But some of these animals are persisting through it, especially ones like Ikembo. Ikembo seems to be able to do it all. But we only see Merodopithecus at that one site. Now, one of the things we're interested in doing is really thinking about the morphology, how these other apes are shaped as well, and trying to think about, okay, how persistent are they? And the other thing is, permit me to arm wave for a minute. Our team was able to push back the dates for grasslands 10 million years. I don't know if you're pushing back dates for some, and anytime you push back a date for anything, it's very exciting, but 10 million years is pretty far. We had recently thought that grasslands aren't taking hold of Eastern Africa, really even existing until about like 10 million years ago in Africa. Like, can you imagine like your stereotypical ideas of Africa without grasses? No. It's very diverse ecologically, just so you know, it's not all savannas. But our dominant idea about how our lineage specifically evolved, like we have all these fossil apes, and truth be told, we don't actually know which ones lead to which apes we have today. But we want to know that. And we want to know which ones lead to us as well. The dominant narrative in paleoanthropology has been that if you're going to become a biped, well, one, why? It's a lot of work. There's a lot of changes your body has to undergo. You're going to have back problems. It's not terribly efficient. There's a lot of kind of bummers about being a biped. Sorry. But the dominant idea has been, oh, it's because of grasslands. It's because grasslands open up, and then you cannot just climb in the trees all the time anymore. It's under this ecological argument. But we don't see good, solid evidence of bipedalism till like 4 million years ago. There's some like iffy things at like 6 or 7, but it's pretty iffy. Why don't we have bipedalism so much earlier? If we have grasslands that are persistent in places across Africa, and we have all these apes, evolution is always trying new things, it's always experimenting. Why don't we have bipedalism in the Miocene? That's my big question. Well, for now, my answer is that it probably isn't an environmental driver so much after all. There's got to be other good reasons to be a biped. And this longstanding idea of that you have to have this environmental driver, you have to have this savanna to start experimenting with being a biped in the first place doesn't hold a lot of water for me. I'm thinking it's probably things like, oh, I have to hold my very helpless baby for a long time because they cannot just hold on to me on their own, things like that. Or maybe like, hey, it helps to hold tools and make tools. It's handy to be handy type thing. But we will see when we have more people looking at this and more people and kind of filling in the gaps between the early Miocene and the late Miocene of this time period. And again, sort of getting back to these other big picture questions, you know, we should be thinking about what is the capacity for our modern apes to adapt. We've always sort of thinking like, okay, our modern apes, most of them are endangered today, and that's no good. If we care about biodiversity, I care about biodiversity, and I care about the living apes. What's their capacity for adaptation? Ikembo seemed like it did a pretty good job. Now, of course, we have to give critters time to adapt, but we should be thinking about environmental conditions here as well. When we're thinking about restoration of habitats, and this was actually a comment that a reviewer had on our science papers. He was like, wow, this is really important to think about grassland habitats and the value of grassland habitats, because usually we're always thinking about, oh, we need to restore it to a forest. And when we're thinking about restoration efforts, I think it's important to have a time frame in mind. When are you restoring something to? Which biodiversity are you curious about and that you want to support? Because ecologically, these organisms are always changing and shifting as well. So how can we be thoughtful about that? So that's my arm waving here. And my take home here is that if you want to get to a place where you're going to do a lot of arm waving and making big statements, then you kind of got to hold some hands first. So that's that. I would like to thank all of my colleagues. Like I said, there's too many to name that have been a part of this research. I want to thank the Kennedy National Museums. I want to thank my friends and colleagues at Cates and at REPO, National Science Foundation, Tacoma Community College, you guys for inviting us, Winterground Foundation, Leakey Foundation. A lot of people have thrown money at us for this work, and thank you. Right.
All right, I'm going to give out some tickets real quick, and then we'll give away some prizes, and we might have time for a couple questions. right. There's entirely too many people in the room to do it this way. I have to congratulate our speaker on having the biggest turnout that we have had since we moved to 7Cs. By far. I apologize to the folks who didn't quite have regular seating, and thank you for grabbing more chairs, folks. Such is what you get when you have all volunteer person who sets things up. So, all right. I should throw these across the table. I should let you know what you're winning because somebody asked if it was fossils. No, sorry, that's not ethical or something. So we give away swag. So we had Grit City Think and Dream T-shirts, and then we moved on to hats. We had socks, and now we're on to beanies. So we're gonna give away 2 beanies. If you keep coming long enough, you will get full attire in Think and Drink swag. So hopefully that'll happen. So do you want to pick one out of the pile or pick 2? We'll let our speaker do this, and then it's her fault. Thank you. Except I have to read the damn number. 1371082. 1082. Oh, congratulations. Yeah, and one more. That's all right. Oh, thank you. And the second beanie goes to last 4 digits, 1106. 110. Woohoo! Awesome. Now she's been coming a long time before COVID, so she now has a hat and a beanie. So that teaches you should come. I will put up, we'll have time for a couple questions if you're okay with it. And if folks need to leave, that's okay. I'll put up the slide again. There's a barcode on the front slide where if you want to join the listserv to be on, and I'll let you know each month what the talk is and so on. That's all I send out to you. If you want to do that, you can scan the barcode, get your name on there, and that way you'll find out about the next talk. The next talk, by the way, is also up there. Danica Miller, who does American Indian Studies here at UW Tacoma, is going to talk about how Tacoma actually tried to try to get out of their treaty obligations with the Puyallup tribe. So she's going to talk about that, her research on that. So without further ado, if folks have questions, raise your hand. Go for it.
Hey, sorry, I talked a little bit long. That was, I just put the talk together this afternoon and yesterday. So thanks for bearing with me. Yeah, you have a question? Yeah, so we are not doing remote sensing. Remote sensing is probably not going to work as well on fossil deposits like this, where we often have a lot of the kind of rocky sediments. It would be really cool to use LiDAR. There are some fossil teams that, well, maybe not. LiDAR is probably not going to work as well. It's not going to pull up like structures and stuff, but we do sometimes use aerial photography. Sometimes you can tell just by like looking at aerial photographs, like, oh, that's a fossil deposit. And part of the ways on Rasinga is like, no one's built a house there. There's no farm there because the fossil deposits are actually not good for farming. So sometimes we can see those sediment changes in aerial photographs that way. There are some teams in South Africa that, don't quote me, they might be using LiDAR, but they're looking for sort of like open cave systems where that sort of like topographic difference is going to pop out a little bit more. A lot of the mapping that we're doing is sometimes it's by hand, so not always fancy. We have done some stuff with differential GPS when we've had access to that. We have mapped sites with a total station as well. And yeah, but I've always wanted to do like fancier, techier mapping, because the maps are, like I said, you only get one chance to excavate it. You only get one chance to collect it. So the more faithful your maps, the better the science you're doing. So yeah, we try. Yeah, thanks. Yeah. Yeah, that's a good question. So the question is, we used to have all these apes. Today we don't really. Where did all of our apes go? And this isn't just like, my theory. This is a published hypothesis, but it's sort of thought about as kind of this competition between apes and monkeys that are sort of evolving in consort at the same time. Now, a lot of your monkeys, they can be similar in size, but they are doing things ecologically just a little bit different. Monkeys tend to focus more on leaves. They can also eat fruit and a lot of the same things that apes eat also, but they're going to be a little bit more leaf dominant in their diets, which honestly, like, leaves are a more surefire diet. Fruit is often available seasonally. Fruit, not every tree is a fruiting tree. Leaves are going to be much more ubiquitous on the landscape. So it's thought that there's sort of like this competition between monkeys and apes, because we do see it would start out with just a few monkeys in the early Miocene, but we have hundreds of monkeys today. We have, just way more diversity in the monkeys. Monkeys also can reproduce a little bit more quickly than apes. So we have a life history thing here as well. If evolution is thinking about like, okay, which traits help you reproduce the fastest and have the most successful offspring, monkeys are doing that better than our modern apes are. We're doing it pretty well as humans. And so we're not having a problem with that competition, but a lot of our living apes, they might be like orangutans, for example. They might be nursing their offspring for like 7 years. And that means they're not going to reproduce again, or more or less until then. And the turnover between like chimpanzee offspring is going to be more like 5 years, whereas humans can have offspring much more quickly. And monkeys have the capacity to have offspring more quickly too. So I think there's a few different things at play there. Probably part of that's ecological. Part of that could also, maybe it doesn't have anything to do with the ecology. Everything has something to do with the ecology, but what, I'm not entirely sure. So, yeah.
All right. I want to thank our speaker one more time. That was awesome. And if you have extra questions, maybe you can stick around for a few minutes, but otherwise we hope to see you in November on the 14th for our next talk. Have a great night.